Hello everyone. Today's video we are going to solve this 35 number question of complex analysis. It was asked in CSIRNET June 2019. In this question they have given us contour in the form of a triangle. Vertices are also given to you in the question and you are asked to find what is the value of this contour integration. To solve this problem, first of all you need to decide the contour. Here the contour is given as delta, and delta is a triangle whose vertices are at 0, a and a plus ia, where a greater than 0. So try to draw the triangle here. This is your 0 and say this is your a, okay, and this point will be a comma a, or in complex field it is this, okay. So this is the complex number, denotes z is equal to a plus ia. So these are three vertices and connect them and you will get this kind of triangle, okay. So here delta is given the counterclockwise orientation of this contour, so this is your delta, okay, and this delta can be broken in three parts. One, say C1, this is C2, this is say C3, okay. That means this given contour integration you can break it in three parts. Line integral along C1 plus line integral along C2 plus along C3, okay. Here denote this one as your I1, this second one as I2, third one as I3, okay. I am doing all the steps explicitly so that it will be better to understand. Now try to calculate I1 separately. So I1 is equal to real of z dz, it is along C1 and C1 is this one, okay. In this C1, along this C1 your z is going to be x plus I into y component. Along C1 it is 0, so z is equal to x, and x varies from 0 to a, clear? That implies the very next step you will have real part of z means x dz, so it is dx, and limit is going to be from 0 to a. Calculate and you will have a square by 2, okay. Now take it, find the value of I2. It is going to be real part of z dz. Now observe along C2, z is going to be, look at x component is a, so a plus y component here it is varying, so I into y, clear, along C2. Now your dz is going to be I dy, and look at the limit of y, it is from y is equal to 0 to y is equal to a, so this one turns out to be limit of y from 0 to a, and real part of z means here it is a dz, it will be I dy, okay. Now just do the calculation and you will have I into a square. Take it. Similarly, try to find the value of I3, and I3 is equal to, along C3, real of Z dz. Now observe, along C3, along this C3, your Z is equal to x plus Iy, but here along this path you have y is equal to x, because this straight line is nothing but y is equal to x straight line. So you have the relation y is equal to x. Just plug here and you will have x plus I. You can write x, no problem. So your dz turns out to be 1 plus I dx, and the limit of x, it is going to be, look at the limit of x, starting limit is from a and the ending limit is at 0. So the limit is going to be from x equal to a to x equal to 0, and real of z, that means x. For dz you will write 1 plus I dx and just calculate it. You will find that you are getting this kind of thing in your hand. Clear? Just do the calculation. Now in the very first step, you have, suppose this is your I and this is your I, suppose this is your I, and you have I is equal to I1 plus I2 plus I3. So just plug the values here and you are getting 1 plus I to a square by 2. Okay, and after doing some calculation you have I square by 2, and it is exactly your second option. Okay, so finally we have the second option as our correct one.